Notes 5b. Solving inequalities. Objective. I can solve inequalities. Essential question. How do I solve linear inequalities? Vocabulary. Compound inequality. Two or more inequalities separated by either and or. Here's and on the number line, and here's or on the number line. Wholes are dashed and open. You either have the less than sign or the greater than sign. Point. It's solid and closed. You have less than or equal to or greater than or equal to. Absolute value. The magnitude of a real number without regard to its sign. The distance away from zero. Writing inequality from graph and vice versa review. R is less than or equal to 5. First, you will see which arrow this is. It looks like this one. And then we find 5, and we put a point above it. It's a closed point because there's a line underneath the inequality symbol. We're going to shade in everything to the left to make it a true statement. For this to work, you need to have the variable on the left side. On this one, we'll put our variable first, and then we put this symbol, greater than -6. There's no line because this is a whole. Solve for x multi-step. We have 7 plus x is less than 3 parentheses 5 minus x, close parentheses. Step 1, distribute the 3, multiply each term by 3. So 3 times 5 is 15. 3 times negative x is a minus 3x. From here, we carry everything else down. So we have 7 plus x is less than 15 minus 3x. From here, let's move all the x's to the left. So plus 3x plus 3x. Add 3x to each expression. 1x plus 3x is a plus 4x. Negative 3x plus positive 3x is 0x. They cancel. Bring everything else down. So we have 7 plus 4x is less than 15. From here, subtract 7 from each expression to get all the constants on the right side. 7 minus 7 is 0. That cancels. 15 minus 7 is 8. Bring everything else down. 4x is less than 8. Our last step, divide each term by what's in front of the x, which is 4. Divide each term by 4. 4x divided by 4 is 1x. 8 divided by 4 is 2. So our solution is x is less than 2. We don't have to flip the relation sign because we didn't divide by a negative. On the number line, it would look like this. We'll put a 2. And we'll put a hole above it. Since there's no line, the arrow is pointing this way, so we shaded the left side. Divide by negatives. Flip the inequality sign. First, we write out what we're given. Negative 12b is greater than negative 24. To get b by itself, we need to divide by the coefficient in front of b, which is negative 12. So divide each term by negative 12. Negative 12b divided by negative 12 is 1b. Negative 24 divided by negative 12 is 2. We divided by a negative number, so we're going to flip the relation sign. B is less than 2. From here to graph this, we find 2, put a hole above it. The arrow is pointing this way, and then we're going to shade the left side. The OR case. 7x is greater than or equal to 21, or x plus 1 is less than negative 2. First, you write out what you're given with this compound inequality. From here, we're going to solve for x for each of these two inequalities separately. To solve for x on this one on the left side, we're going to divide each term by 7. We divide by what's in front of x, the coefficient, to get x by itself. 7x divided by 7 is 1x, and 21 divided by 7 is 3. X is greater than or equal to 3. On the right inequality, we have x plus 1 is less than negative 2. Subtract 1 from each expression. 1 minus 1 is 0. Those cancel. Negative 2 minus 1 is negative 3. Bring everything else down. X is less than negative 3. Carry down the OR. This is your solution. X is greater than or equal to 3, or x is less than negative 3. So we find 3, and we put a point in front of it. X is greater than that, so the arrow is pointing this way. So we're going to shade in the right side. Then we're going to find negative 3 and put a hole, because there's no line, underneath this less than symbol. The less than symbol is this way, so we shaded the left side. The absolute value of x plus 1 is greater than 5 means x plus 1 is less than negative 5, or x plus 1 is greater than 5. This is just another notation for the OR case. The AND case. Negative 20 is less than or equal to 4a less than 20. First, we rewrite our given compound inequality. For this, we are going to do the same steps for all three sides, for all three expressions. So we want a by itself, so we're going to divide each term by 4. There's 3 terms here. Negative 20 divided by 4 is negative 5. 4a divided by 4 is 1a. And 20 divided by 4 is 5. We didn't divide by a negative, so we just carry down the relation symbols. Our solution to the compound inequality is negative 5 is less than or equal to a less than 5. We find negative 5, put a point above it since there's a line, and then we find 5 and put a hole above it. Since a is in between these two numbers, you shaded between the 2 points that you graphed. And this is another way to write this inequality.